larger than that one.
Pardon?
Can't be any larger than that one.
Unfortunately, you're mixing units because this has different units than this one. Remember that now? What are the units of KC, by the way? Oh, I didn't, that's what I was getting to. Okay, units of this are what, Jerry?
It's temperature.
Temperature, degrees Celsius. What are the units of this thing right here? Percent, exactly. So, the reason I know that is because we've been doing N as percent, and the output for some of you is degrees Celsius, or some of you it's other stuff, pounds per minute, or pressure of water, or flow of liquid, or whatever. So K has to have the units for this system of degrees C per percent so that the units work out. Because this times this is equal to this. And what are the units of this? Degrees C.
That's a reciprocal.
Pardon? No, these are degrees C. Because this is degree C, this is degree C, you subtract one from the other, you still have degree C. For error, I'm pointing at the error signal right now. And this has the units of percent, so what are the units of this have to be so that you can multiply this that has degree C and end up with percent? Percent per degree C. Did you say it wrong, Nicholas?
I said it wrong.
Say it correctly.
Percent per degree C.
Stand up and state your name and your team name and say it correctly. Complete sentence.
Good morning, my name is Nicholas Payton.
Good afternoon.
Good afternoon, my name is Nicholas Payton, and the units for KC are percent per degree C.
Excellent, thank you. One clap for that. Now, what are the output units for your system?
Centimeters of water.
So stand up, state your name and your team name, and say what the units of KC will be for your system.
My name is Nicholas Payton, and the units for KC will be percent per centimeters of water.
Excellent.
Green team.
Green team. Alex B., what are the output units for your system?
Pounds per minute.
Would you stand up and state your name and your team name and state what the units of KC will be for your teams?
My name is Alex Dudley. I'm with the Buff team. It'll be percent per pounds per minute.
Excellent. Clap for Alex. All right, altogether, what will the numerator of the units be for KC for your system?
Percent.
And what will the denominator be for the KC for your system? Whatever the units of the output are. Okay. Are you with me there? So, why did I digress on that? Probably just because I wanted to, but I think it has something to do with this. Oh, that's why I know that the units have to be percent per pound per minute. Now, whoever did this may have just made a typo there, but it's something to check into. Let's go back up here. This one doesn't have the units of KC. That's the way to be safe. Don't put any units on it. Odd. This one has units on KC of percent per degree C. So this one has the right units, I believe. Wrong units. Nice graph. Oh, this is, okay, so here's the full relay feedback test that this student ran, and they circled in that section. They're going to do some exploration of delta C. This is pounds per minute, so it must be flow. What do you notice about the units here? You like them? Oh my! What do you say, Marion? It's wrong. Yeah, that's one way to put it. Yep, upside down. That's the best. Here's the KCU of 248 degrees C per percent. Any thoughts about that one? Pardon? Say it again.
240, I just seen a real high number.
This one?
A real high number.
Seems like a real high number. Guess what? Your job isn't to judge the numbers of other people.
That's what was wrong with it. That's the first thing we jutted out to.
No, you don't know their system. This is temperature. They may have a very high number for KC. Let's look at the units for a minute here. What are the units? They're wrong because percent is always in the numerator, not in the denominator. What do you notice about, oh, here's one, Tyler. What do you think about that number for KC? It's too big, isn't it? It's a real high number. Marion, what do you notice about the units of the KC? Huh? They're wrong, upside down.
What is it, even if you flipped it around, it would be 117% per degree C.
That's right.
You have to turn up the system 117% to get 1 degree C.
That's what it says. and there's nothing wrong with that. That may be right. It may be, they may have gotten the reciprocal of that also. I don't know. Never run that temperature. And there's the last one. All right, so here's what I'm going to do now. I'm going to show you how to take your data. You got enough energy, maybe 10 more minutes?
Oh, yeah. Yes, Doctor. Yes, Doctor.
What time are we supposed to be out of here? Okay, 7 more minutes. Here is the spreadsheet that I downloaded from the web, that you can download from the web. Here's the spreadsheet, it's got all these things on it, nice graphs and all these stuff. I don't know where these come from, but we'll worry about that later. Now, I got another spreadsheet here that has some real data on it from one of your students, from one of your colleagues right here. I'm going to take this data, copy it, I'll tell you what I'll do. I'll make these so I can do them side by side. You like that? That's not what I want. Where's the other data?
I think it's behind. There it is. It's in the same window, but there's 2 sub-windows.
Okay, so make that bigger and make that smaller, right?
Yeah.
Thank you. I'm going to put the students' data there, and I'm going to put the model data over here. This is the one on the right off the web. So here I'm going to take the frequency. I copied it already. I'm going to click there and paste the values. You with me? I'm going to take the amplitude ratio. Do the same thing. Copy. Paste the values. So these numbers are now those numbers. So here's the graph that automatically changed. Did you notice the graph changed? Y'all are smart. Need to, now then, I'm going to, look at that. I don't have to change these. Oh, there's an equation in there, I bet it says equal that. How come I can't see the equation?
It's up there at the top bar.
Right there. Okay, thank you. But the phase angle I need to change. Let me go over here and take these numbers, copy and paste values. So that's done. Now then, can I, how can I, oh, I know what I can do. Okay, here's the one off the web, and I need to plug in the uncertainty. So here's the AR uncertainty. Copy. Paste values. And here's the phase angle uncertainty. Copy. And paste values. Now then, I've gotten all of the data off of the experimental sheet and look at, oh, you know what? This student has positive phase angles and I want to change those all to negative. Does anybody know how I can change all those to negative real easily?
The equal negative in front of it.
Pardon?
Put an equal negative.
I'll tell you, I'm going to put these over here, and then I'm going to say for that one, equal minus this. Is that what you're saying? Cool. Now then, notice that they showed up here. All right. More than one way to peel a tomato, so they say. Now then, the model equation that was on that web page a few minutes ago is this for the phase angle. Sorry, for the amplitude ratio, and here for the phase angle. Pretty good agreement, right? No, pretty sucky. Because I haven't changed any of these parameters to make them agree. These are the parameters that are in those curves. So what should I do to K, to get it lower? Let me show you. I'm going to make it 0.2 instead of 0.3. Hey, that lowered it. How about I change it to 0.15? Right on! And my guess is that's the K for this system. Now then, I can't change the T0. The order has to be K, I have to change K and tau for this graph. Can't change T0. It has no impact on this graph. I'll tell you why in a minute. I'm going to change tau. Let me make it larger. Does that help? Let me undo that. You're going to have to watch carefully here. It's 0.6, and I'm going to change it to 1. You tell me what happened. Is that better? What about 2? Better? That's 1.1. That's something you're going to have to decide upon. One thing that's cute is this is a first order model, and so at high frequency it has a first order slope, same slope as first order. Now, cannot change those two numbers again.